Okay, in this short lesson, we're just going to have a brief look at experimental uncertainty. And you can see that I started this off with a little quote. And this quote actually comes from the IB syllabus, oddly enough. And it says, "One of the aims of the physical sciences has been to give an exact picture of the material world, or as the world around us. One achievement of physics in the 20th century has been to prove that this aim is unattainable." We try always to give an exact picture of what's happening in the world around us, but in truth, that picture, that exact picture, is completely unattainable, which basically means that every measurement we really take in physics has a certain degree of uncertainty to it. Okay, I'll let you guys read through some of this yourselves. It's straightforward enough. So I decided just to put in one little thing on absolute error. Now I'll go into further detail on the other types of error that are there. But right now we're just going to look at uncertainty as the range or the spread of values in an experimental data. So you can see that the data that's given to us comes from actually Hooke's law. Okay, so you've got the mass of an object, so you've got the mass applied, and you've got the extension from the equilibrium point of a spring. But it doesn't really matter, to be honest, what the experiment is about. What matters is how the error looks as regards the data. Okay, so we've got one of my data points. Let me just try my new stylus here. One of my data points is 0 millimeters, so it's giving me an extension of 0. The other one is giving me an extension of 1. When you average the two of them, you get 0.5 millimeters. Okay, so the point here is that that average is only as good as the spread that's on the data. So you would notice that the 0.5 is exactly 0.5 away from 1, and it's also 0.5 millimeters away from 0 millimeters. So that means that the absolute error here on this would be plus or minus 0.5 millimeters. Okay. So notice the unit comes in here, and we use this plus or minus symbol as well. If we look at the next one, we've got an extension of 5 millimeters, and then we've got an extension of 6 millimeters. Our average is 5.5 millimeters. And again, if you look at where the average is, again, we've got 0.5 millimeters away. This one is 0.5 millimeters away. This one is also 0.5 millimeters away. So that again, you've got plus or minus 0.5 millimeters would be what's called the absolute error. Now, if you look at this one here, we've got a 9, and of course the average of 9 and 9 is still 9. So that means this one is plus or minus 0. So in theory, it should be a perfect result, but in reality, of course, that's not going to happen. So I'll let you guys just have a look through the rest of them and make just a little note of the absolute error for each one that is in this data table.